Okay, and how many spaces between deci and centi? 2. So you put 2 zeros, and then because both units were cubed, you did what? You cubed the numbers. Now, when you punch that in, you should have gotten a pretty big number. So 35.6 times 100 raised to the third. That? Is that what y'all got? Okay. Now, we're going to talk about how to put that in scientific notation in a few minutes because I don't want to keep writing all those zeros today. All right, in the last question, you had 28.7 liters, and you had to change it to centimeters cubed. So, if we look at that one, what do we know about a centimeters cubed from yesterday? It has to be milliliters, right? It's one and the same. So, 28.7 liters, liters to milliliters. Who's bigger? And how many spaces between a liter and a milliliter? So to calculate 28.7 times 1,000, like that. Any questions? Do we feel okay with the material that's on there? Would we be okay with any of that on the quiz tomorrow? If I asked you anything like that? Yes? No? Okay. Can we talk homework? See how we did on that? Okay. All right. So if we look at our homework questions. Number 1, decimal 0.156. Decimal 0.156. Number 2, 1.25 hectometers. Number 3, decimal 35 decameters. Number 4, 650 hectometers. Number 5, 16,840 millimeters. So 16840 millimeters. Number 6, decimal 3 zeros. 156 kilometers. 7 is the same thing. So 15.6 centimeters cubed. And number 8 is 965 centimeters cubed. Sorry, 965,000 centimeters cubed. So 965 and 30 centimeters cubed. Questions? Anybody need me to do any of those 8? So we got all 8 right? You need number 2. All right. My guess is that you got meter and hecto mixed up with a milli. So you have 125 meters and you're going to hectometers. So when you look at the King Henry died by drinking chocolate milk, here you've got milli and hecto. Now, my question is, did you remember that meter is here, and that's the meter we're talking about, and this is milli down here, so that would be mm. So you'd have to have 2 m's.
Don't want to say that, but meter is bigger.
Okay. Okay. Well, that wasn't the mistake I was thinking you made. A lot of people see this m, and they think it's this. Okay, and it's actually this. So that was my guess as to what you did wrong. Okay, so hecto would be bigger, and you would say here to here, which would be 2 zeros, and do that. Anybody else have a question on anything in the homework? So we got all the answers right. So I'm going to grade a bunch of excellent papers tomorrow. Now, y'all better not disappoint me or I'll be suicidal when I go home. The standing joke in my classes last year was I was going to become an alpaca farmer because I sucked at this job. All right. Let's talk scientific notation. Do y'all all have a calculator? Okay. Let's talk about the one we just did a second ago. Where was that question at? Right there. 35.6. What was the unit on it, so I have the unit. Decimeters cubed to millimeters cubed. All right, decimeters cubed. To millimeters cubed. All right, so if we get a number like this number is going to be gigantic, right? Now, we had a number just a second ago when we wrote it down. Oops, I did not land in the right spot. That was like this. This number is huge. And because this number is huge, scientists invented a system many, many years ago called scientific notation. And so we're going to use that system throughout the course of this semester. So I don't have to keep calling out numbers with zeros and decimal 000 or 35,800,000. We can put these in scientific notation. Now, somewhere in your math background, best guess as to where this would have fit is probably Math 1, maybe middle school math. Not sure exactly, but somewhere in your math background, you would have talked about scientific notation. And you would have talked about the fact that this is notation for very small or very large numbers. Okay? It's notation for very small or very large numbers. Now, scientific notation is always going to have a number between 1 and 9. And then it will have a decimal. These numbers can be as many numbers behind the decimal as you want. And times 10, and it will have an exponent. So, an example of this might be something such as 6.15 times 10 to the 7th. This 6 is a number between 1 and 9. Here's two numbers after the decimal. It could be more, it could be less. Times 10. And the exponent in this case is a 7. Okay, that number is in scientific notation. Now, we're going to talk about ever so briefly how to put them in and take them out of scientific notation, just as a quick review so you have a brief memory of how you did it and took it out in case you forgot. But we're going to largely let the calculator do the work. Okay? Does everybody have what they want? Do I need to wait? No? All right, so let's say that we have a number like 458,000. Where do you know the decimal is at in this number? The what? The end. Okay? We understand that there is an understood decimal right there. Everybody knows that, right? Now, we have to move that decimal to a number, behind a number so that it will be between 1 and 9. So where does it need to move to? That's right. So it needs to move 1, 2, 3, 4, 5 places. So it's right there. So this number is going to become 4.58 because that number 4 is a number between 1 and 9. If I stopped behind the 8, Would 458 be between 1 and 9? No. If I stop between 5 and 8, would 45.8 between 1 and 9? No. That's why we went all the way to between 4 and 5, because 4 is between 1 and 9. Does everybody understand why Andy said go there? Okay. Now, we write times 10. Now, the exponent is the number of places you move the decimal. How many places do we move the decimal? Then the exponent is a 5. Now, most of you probably remember, if you move the decimal to the left, it's a positive exponent. So in this case, it's a positive 5. If you move the exponent to the right, it's a negative exponent. So, if we have a number such as one that you might have had in your homework, like this one, where would we move the decimal to this time? Where? Can't hear you, Eiley.
The right.
To the right where? How far? Between the 2 and the 8, okay? Oops, let me change my color here so I got a little shading variation. Okay? So 1, 2, 3. I'm going to move it 4 places to between the 2 and the 8. And that's a good choice because the 2 is between 1 and 9. So we have 2.84 times 10. And how many places did I move it? So my exponent's a 4. And Eileen said we went to the right. So it's negative 4. Now, if that is something you're like, I don't know what that crazy one was talking about. That's too far back in my math memory. Do not panic. The calculator will do the work for you. Okay? Now, we all have a calculator in front of us, right? So, let's let the calculator do the work for us. Suppose, everybody got what they wanted off the board? All right. Suppose that we had a chart in front of us, and it had 12.81. It had 1 here. It had 10 cubed there. And I told you your answer had to be in scientific notation. All right. Punch that in your calculator. Some of you will get scientific notation because your first period friends probably didn't fix your calculators. All right. Now, when you did that, what'd you get?
12,810.
Now, is that answer in scientific notation? No. Now, let's say for a second you are scientific notation challenged, and you're like, I can't move that decimal, Miss Wall. That is way too complicated for me. How can you make the calculator do the work? Who remembers from math class? Y'all sound like first period now.
Oh.
Somebody here knows. I feel it.
You at move.
Okay, we're on the right track now. We did it faster than the first period.
All right, and then once you click mode, you go right.
2. There you go. All right, they want to hit math, stat, all kinds of other weird stuff. All you have to do is use your mode key. Hit mode, hit sci, hit enter. And then hit clear. And your calculator is now in scientific notation. It will calculate your answers for you in scientific notation. If you don't want it to calculate in scientific notation, all you have to do is those same steps, except put it back in normal, and it will change it back to normal notation for you. You don't have to calculate in scientific notation. Okay? So, if I want that answer in scientific notation, if you didn't mess up on the calculator and you followed those steps, all you had to do is hit enter again and it will change your answer. Okay, if you messed up the steps, then just punch it in the calculator again and it'll give you your answer. Now, when it pops up on the calculator, you got 1.281 E what? Now, this is not your answer. You have to change the answer into scientific notation. So how do you write the answer now? Times 10 to the fourth. This is telling you what? That's telling you what your exponent is. So if you write 1.281 e to the fourth, I'm going to take off a couple points for not translating your answer into scientific notation. You have to translate that into scientific notation. The calculator is just saying, hey, this is your exponent to put on your times 10. You have to write the actual times 10. Everybody okay with that? Yeah or no? Am I going too fast? Okay. Now, can we use the scientific calculator to punch in scientific notation? Have we used that before? Don't know. Okay, let's try that. Everybody got what they need? Cameron, you got it? Okay. So let's say that you have a problem like 4.52 times 10 to the 8th times 6.17 times 10 to the 9th. All right. How do we punch this in the calculator? First of all, do we ever say times 10? The answer is no. We have a scientific calculator. The scientific calculator is going to allow this times 10 to use a special button on our calculator. This times 10 is EE on the calculator. So, look for your little comma on the calculator. It's above the 7. And right above it is an EE in yellow, which tells you you need to use what? If it's above it in yellow, the second function. So, you're going to put in the calculator 4.52 second EE, and what pops up on your calculator when you do that? Punch it in your calculator so you see it. An E pops up. The calculator is already programmed with times 10. It's saying to you, what is your exponent? So you tell it 8. The parentheses mean to do what? So times 6.17. And then you've got another times 10. So you do what again? Second. And then EE. And when you hit second EE, what happens again? You have an E. So it's asking you again, what is the exponent? So what's the exponent? 9. Now you hit equals, and you get an answer. What'd y'all get? Because I don't know this off the top of my head.
2.7884.
Hold on, 2.78 is plenty. 2 places for right now. I'm going to teach y'all how to calculate with significant digits tomorrow and Thursday. 2.78 times 10 to the 18th. Everybody get that?
Yep.
Questions? Think we can try it?
Yep.
Okay. Everybody got what they want before I take this down?
Is the scientific notation going to be on tomorrow's?
You may use it on tomorrow's quiz, but it'll be on the next one. Actually, be on the third one. Meaning, we're going to practice it with conversions very shortly, and I will let you choose which way you want to show your answers tomorrow on the quiz. You can show it in normal notation, or you can show it in scientific. All right, so I want you to use your calculators, and I want you to calculate. Okay? Show me your answers. You don't need to write them down. The answers, that is. Don't leave them on your calculator in case you accidentally hit clear or delete. It's mine. I only did 4 of these in the first period. Like I said, rounded 2 places behind the decimal for today. Anybody have a question? Want me to come look at it? Anybody need help? All right, everybody done? I looked it up at press pictures of Houston. Just think, if we were all there, we'd be swimming. We'd be in school today. Anybody have a question on how to use a calculator? Can I call out the answers? All right, question 1. 4.78 times 10 to the 7th. I see nods, yes. Got it. Number 2, 7.92 times 10 to the negative 17. Yes, no? Okay. 3, 2.1 times 10 to the 5th. Okay. Number 4, 1.32 times 10 to the 11th. Yay, nay? I see only a couple heads nodding. If y'all don't nod, I don't know. Number 5, 6.87 times 10 to the 4th. And the last one, 1.18 times 10 to the 10th. So do we feel okay with how to use the calculator? All right, now we want to practice our converting for the quiz tomorrow in both systems. All right, so let's say that tomorrow on the quiz that you have 4.18 meters cubed, and I want you to change it to decimeters cubed. I want you to write the answer in normal, which is also called fixed decimal, and scientific notation. Okay? So, how do we set this up? What do we do? Okay? And on the bottom?
M3.
On top?
DM3.
Okay. Andy's done his part. Somebody else step up. What we gonna do?
Figure out which one's bigger.
Who's bigger?
12. This week.
You think?
No.
Maybe y'all are like me. Y'all are visual. Y'all like the pictures. Where's meter at?
Base.
So who's bigger? Yep. How many spaces between meter and deci? Okay. What do we think about that question? We need to do anything else?
Cube.
Okay. So I'm going to put a cube here and a cube there. All right. So calculate it. Oops, stupid, should turn on the calculator. So when Ms. Wall calculated the question, my calculator is still in scientific notation. So that's what I got. Now, that's one form of the answer. So what am I going to do to get the other form? Okay, I can either switch the mode or I can move the decimal, whichever one I like better. All right, I tend to be lazy. I like the mode, but I've done this long enough, I can just move the decimal in my head. All right, and there's the other answer. Everybody good with that? Now, the reason I want you to be able to do it both ways is we're going to take a multiple choice test next week. It's one of the few that we will do that's entirely multiple choice. The vast majority of the tests that we will take in here are not multiple choice. They're mostly for response. But this one happens to be multiple choice. And you do not know which questions will require the answers to be in scientific notation and which ones will require the answers to be in normal or fixed decimal. So you need to be able to go between the two. We are not doing the whole page. I'll tell you which ones we're going to do in a minute. We're going to do about 6. Alrighty, so let's do let's do 3, let's do 5, let's do 7, let's do 10, let's do 12, and 13, because 14 is going to be way too big for switching. Let's do those 6. And I will walk around and be a pest. Anybody have a question? Sure, you run anywhere you want to. Hmm? Yes, both ways. Anybody have a question? Want me to come look over your shoulders and be a general pest? Oh, 52 weeks a year. There are 52 weeks in a year, in case you don't know that. Okay, so that's in that one. Now do the second answer and then do the scientific notation. So say move. That. And then write that one down too. What's wrong with the 5? Bigger. Put 1. And then this one is 52. And this is good. Okay. Same one. Still subject to chart, 14 years. And then yours still goes on the bottom. Week still goes on the top. Who's bigger? Mm-hmm. And how many weeks does that take in a year? Mm-hmm. Mm-hmm. Exactly. Okay. Uh-huh.
Either way, 27,
It's not gonna come out, you're gonna have to move the decimals, because that, number 7, when you get that one, is not gonna go to normal notation, no matter how many times you do it on the calculator. You're gonna have to move number 7's decimal by hand. You got the same problem. Are you over here? You want me to stop this? Stop it outside class. Yeah, just quiet home. Your brothers and sisters. They just quiet people. You just quiet in the crowd. Mom just love you. Or take you home with me and trade my son in on you. You said that I'm gonna take you home and drop him off. Yeah, you just put it at the end of it, so after your times 10 to -1, you just put it at the end, it's like that. Yeah, Brandon. Okay, so how many weeks are needed? It's 2. You just write 2 up there, and then you calculate just like you did number 1. So you just multiply. Question? I'll answer it if you have one, or you can keep talking to yourselves over
When it's the negative x, what, which way do you move it?
there. Left. Yep, you gotta make it a smaller number. Hurt yourself?
I pushed my back.
Oh. Mhm. 10 questions. Anybody else have questions? Generally kind of useless. I hate small classes like this. I get bored. So I read the news, and then I get depressed. It's nothing good with me. How are we coming? We getting close? If you didn't get them all done, that's okay. As long as you've done at least, I gave you 6. As long as you get at least 4 or 5 of them done. All right, there are the answers. So check what you've got. See how we did. All right, so what you think? Yay, nay, do we need to go over some? What do you think? Now, tomorrow on the quiz, you could give me your answer in either form. I will not care if your answer is in normal notation or in scientific notation. Somebody first asked me if you could do it in both. The answer is yes, but if you do it in both and one of them's wrong, I will take points off for the one that's wrong. So I would tell you to pick one and go with it. Okay? So, anybody need to work any of those 6 that you just put on the board? Anybody get one wrong? Yes, ma'am. 10? Okay. So, in number 10, y'all did what? 7 kilometers and you went to decimeters. All right, so 7 kilometers. Kilometers on the bottom. We're going to decimeters. King Henry died by drinking chocolate milk. All right, so who's bigger? Okay, and how many spaces between Killy and Deci? Okay, 1, 2, 3, 4. So we got 10,000. So 7 times 10,000 is 70,000, which is 70,000 decimeters. And when you punch that in the calculator and switch it to modes, you get 7 times 10 to the 4th decimeters. Okay. Anybody else? Question? Yes, ma'am. 13. All right. 13 says 5.87 centimeters cubed to decimeters cubed. Okay. Centimeters cubed, decimeters cubed. All right. King Henry died by drinking chocolate milk. All right, who's bigger, a deci or a centi? Okay. So we're going to put 1 next to deci. How many spaces between deci and centi? All right. What's different about this question and that question? It's cubed, so I'm going to cube the 1 and the 10. So when I do that, I have 5.87 divide 10 raised to the 3rd, and I get 5.87 times 10 to the negative 3rd. And if I change that into normal notation, I get those like that. Anybody else? Question on any of the 6 we just did? You feel okay about them? Okay. Do we feel better about what's on the quiz tomorrow? Now, don't let that be said without that other stuff we talked about, like units and SI units and common units. Don't chuck all that stuff and be like, I ain't looking over that stuff. I'm good. All right, because you might see that stuff too. All right, let's talk density, which is the last part of what's on the quiz. Now, density, you guys studied back in middle school, so we're just going to hit some highlights. Okay? Now, somebody tell me what you remember about density. I remember something about density in middle school. I feel certain somebody remembers something. Nobody remembers any kind of words from density? No kind of words. Okay. Density is mass per unit of volume. It has a formula. D equals M over V. If you were taking a physics class, they would use the Greek letter rho. Why we can't agree on physics and chemistry, I have no earthly idea. But in physical science and in chemistry, we use D. In physics, they use rho. Now, somewhere in your vast science background, you probably did some kind of experiment or had a discussion where maybe you had some water, had some oil, and you talked about why water and oil separated. One went up and one went down. Anybody remember why we talked about that? Okay. Can you tell me which one was more dense? Okay, I got some up here with the oil, I got some with the water. All right. The water, since it's at the bottom, is more dense. Whatever's at the bottom is more dense. More dense sinks. Okay? Less dense floats. So, any of y'all work somewhere? Fix soft drinks? Nobody works? Nobody has to fix soft drinks, tea, anything? If you ever have to, when you do that, you will find that ice does what?
Float.
It floats. Why does the ice float?
Because you drink and then it's less dense than ice.
That's right. What's less dense? The ice is less dense because the ice went where? Went to the top. Now, that is an anomaly for most of us. Most of us know from another science class that which one is more dense, the solid, the liquid, or the gas? The solid tends to be the most dense, then the liquid, and the gas is the least dense. Now, ice being a solid, most people would think, oh, the ice is the solid, it's going to be the most dense, it's going to the bottom. But ice is a solid and it's less dense, it floats. We're going to talk about why that is this semester. But a typical example would be some kind of salad dressing that you guys like an oil and vinegar, an Italian salad dressing. What do we all do with that before we put it on our salad? We shake it up because as it sits, the oil floats up, the water floats down. A lot of y'all have had driver's ed. When did Mr. Mormon tell y'all the most dangerous time was to drive after it started to rain? What's the most dangerous portion of the rain? When it just begins, because the oils on the road begin to do what? Float up, okay? And that's because the oil is less dense, so it starts to coat the surface of the roads and the roads become more slippery, okay? Again, all has to do with density. Now, we want to talk about how to calculate with density today, more with the units than anything else, because I think the math will be okay. All right, I have some problems with these so that y'all don't have to go, what's that say? Now, these should be pretty easy, I think. Cool. All right, so in the top one, it says, what's the density of an object? All right, I'll give you a moment to write that down. I'll hand out a chart. If I were you, I'd write my name on this chart. That way, if you leave it in here somewhere, we can get it back to you. We'll leave this chart all semester. All right, we had to have a right. So what they're asking you to find? Nice and easy, find a density. Now, sometimes the word problems are so easy, it will say mass of 12 grams. Sometimes it won't be that easy. It'll just say 12 grams. One of the reasons that we spent time with units yesterday is so that if it doesn't say something like mass of 12 grams, you can look at this and go, oh, it says grams. I know grams is a mass, so if it's grams, it has to be a mass. So if the formula is this, and I know I'm looking for density, I know 12 grams has to go for mass. Now, 3.89 milliliters has to be a what? Has to be a volume. Now, the reason that we're doing this particular question is to talk about the units. So to solve, it's nice and easy, punch it in the calculator, because all we have to do is divide, and we get 3.21. Now, when I look at those units, what can you tell me about those two units? Do they have anything in common? Does this and this have anything in common?
No.
No. So are they going to cancel each other out?
No.
No. So when I go to write my answer, I have to write both of those units. I have to write grams per milliliter. I have to write both of them. So I'm going to write 3.21 grams per milliliter. I'm keeping both parts of the unit. I'm not dropping anything. Okay? Now, when I look at the second question that I wrote there, the units are going to work different. So write that one down. We'll talk about how that one's different. I opened it, I looked at the parts and decided it was more complex than I wanted to deal with today, so I closed the box back up. It had a bunch of parts on it. Don't look at me that way. I'll get to it. This won't be today. Maybe tomorrow. What I really need is my husband to say, I'll come to school and put it together for you. I just need to go home and look sad. And I feel bad because he gets up at 3:30 in the morning. He owns his own truck and he delivers furniture, so he drives to Charleston every day and drives back. Yeah. All right, so what are they asking us to find here? And what volume? Now, this is one of those that I would tell you that those of you who have great math skills, solve it any way you want to. You will never hear me complain, okay? They're asking you to find volume, so we have to have density and mass, right? So what's the density? 5.64. See how it said density of? So 5.64. What's my mass? Now, if you have great math skills, this is what I was talking about just a second ago. Solve it any way you want. Multiply by the inverse, reciprocal, whatever the method is your math teacher taught you to solve with, go for it. I am not going to complain. If you have weak math skills and you're looking at it and you're like, I multiply or divide in this wall. The method I always use in class is I cross multiply. Mainly because if you get rid of the fraction, nobody in here is going to ask me that question. So get rid of the fraction. V times 5.64 is 5.64 V. 1 times 89.5 is 89.5. Now that I've got rid of the fraction, does anybody have a question about how to solve for the V? No, because everybody knows is multiplied, and what's the opposite of multiply? Divide. So we're going to divide by 5.64 on both sides. So V will be whatever that is. 89.5 is 15.8. 15 point what? 8 is fine. One decimal place works right now. All right, now check your units out. This one has a gram over milliliter, and this one has a gram. So what's going to happen when we divide those 2 grams? They're going to cancel out. And so they're going away this time, and we're just going to have milliliters. See the difference between this one and this one with the units? The top one don't cancel, and the bottom one does. Everybody cool with that? Okay. Now, I want you to only do the top one. I don't want you to write that down at all. Just write the orange one down. And then I want to see what you can figure out. This is as far as I got first period. All right, so you can figure it out. At first. Gotta do that part first. All right, so those of you just sitting there got it figured out, right?
Yes.
All right, so what's the answer?
Lead.
All right, I got an answer of an element, which is what I should have. I should not have a number answer. It says, what is the identity of a material? It doesn't ask for a number. So those of you who gave me a number, what's the piece you're missing? What did she do the rest of you didn't do? What I give you that you did nothing with? She was trying to be subtle over there. It's not working real well. See that blue chart? Not gonna work out real well for you. Now, on the first page, down towards the bottom, there's a whole column that says density. First of all, this is a table of reference. It's a reference table. The state of North Carolina is going to give you this on the exam. All right? Since the state of North Carolina is going to give you this on the exam, first of all, it'll be on nicer paper. It'll be a booklet instead of stapled together. And in the center will be a giant periodic table. I'm going to give you one of those too, but mine will be on one sheet of paper, not two pull-out papers. I'm giving it to you also so that you can learn how to use it throughout the course of the semester. So if you should have a question like this on the exam, and they're asking you what is the identity of a material, is the question going to say, look it up in the reference table? No. You're going to have to figure that out on your own. Okay? So Now that you have your answer that you just said of what was the answer for the density, okay, so you said 11.34. So everybody said density equals 314 grams, 27.7 milliliters, and you got 11.34 grams over milliliters. You got the density. Beautiful. Now, take your blue reference table, find the column that says density, and match it up to an element or a compound in the chart that has a density of 11.34. And I'm assuming that Sheena found lead, given that's what she yelled out. Okay, did everybody find that too? Fabulous. All right, there's one more question I want to do, and then I'm going to stop for the day. And that would be this one, which causes all kinds of havoc on the test. People look at me and go, what on earth do you want me to do with this thing? So I would recommend writing this one down. You will see it again. Huh?
Chart two.
Yes, the chart's the important part. And the ugly picture. Now, as you're copying that down, tell me what your thoughts are on what to do with that. Say what now?
We have to figure out which object goes in which slot.
Uh-huh, you did. So what are we going to do to figure out what object goes in which slot?
Figure out the density.
Okay, so we're going to figure out the density of each. So, the density of object 1 would be what? Okay, density is 5 here. So density here. Let's get the actual number in case we have another one that's close. Okay, clearly I did not punch that in right because that answer was not right. There we go. All right, and object 3.
3.
Okay, and the last one. Okay, so we've got the 4 densities. So based on our discussion about density earlier, what is going to happen?
The more dense sinks.
All right, the more dense sinks. Okay, so if more dense sinks, where's it going? All right, so who's going to the bottom? All right, so object 4 is going to the bottom. Okay, then what? Okay, then, and last. Very good. Any questions? Everybody with me? All right, I'm ahead of where I need to be first period by a long shot. Let's talk about that one ever so briefly. This one always causes issues when I put it on the test. And it will be on the test. Tell me what is wrong with that question. Tell me what causes problems on the test.
Volumes is leading.
Mm-hmm. And the volumes have to do what?
Cancel out.
That's right. They have to cancel out. They have to match. And they don't. So how do we fix it?
Great.
Convert which one?
Liters to milliliters.
That's what I do. Now, the problem that students usually have, or what they try to do, is a lot of times people will look at this and they will want to change this one and convert it. Why do you suppose I tell them to leave this one alone? Because it's a what? You can convert this one. I'll be glad to show you how. But this is a what? It's a fraction. Most people don't like to change fractions. They don't do it well. This one is not a fraction. So if it were me, I would change the 0.054 liters into milliliters, and then I could just go ahead and plug it into my density equation because my units then will match. Okay, so I would have 54 milliliters. Now I have milliliters, and then I have milliliters here, and I can plug in and solve. Does that make sense? Okay. Now, for homework tonight, since again, I am much further ahead of where I need to be first period. You remember your homework sheet from last night? I want you to do the last 3 questions. There's 3 density problems just to practice what we were just doing, just to make sure you're okay on the last 3 things that are on, last thing that's on the quiz for tomorrow. Okay? So if you'll practice that,